All right, this is the video for Math 1 Honors. We're going to do 10.8, which is really just sort of putting together all that you've learned in Module 10. There is a warm-up to this task, but I feel like we just did this part in 10.7. But I do want to do this third one on the warm-up because we really haven't gone from vertex form to standard form, factored form yet. So I wanted to make sure that you knew how to do that. So it says write the following function in standard form and factored form, then find the x-intercepts, axis of symmetry, vertex, and y-intercept. Okay, so when you see this vertex form, I don't want you to make this mistake. Okay, this is not y equals x squared plus 4 squared minus 9. Okay, it's not that. You can't like distribute this exponent over a sum, only a product. So make sure you don't make that mistake. If you're going from this to this that quickly, you're probably not doing it right. Okay, so actually what we want to do is we want to FOIL this out. So really, to start doing standard form, we really want to write y equals x plus 4 times x plus 4 minus 9. And then we can FOIL this and then subtract the 9. So I have y equals, and then this is x times x, which is x squared, plus 4x, plus 4x, so plus 8x, and then plus 16, right? 4 times 4, and then minus 9. All right, so your actual standard form is going to end up being y equals x squared plus 8x, and then 16 minus 9, which is 7. Okay, so here's your standard form. Notice that it is not this, right? Okay, so now you're going to factor it. So you want to find numbers that multiply to 7 and add to 8. So, well, there's only two numbers that multiply to 7 since it's prime. So that's 1 and 7. So since our a is 1 here for our standard form, I can just take these numbers and that's my factored form, x plus 1, x plus 7. Okay, so here's my factored form. And from the factored form, what the factored form does is it helps us to know the x-intercepts because the x-intercepts are whatever's going to make this 0. So what's going to make this quantity 0? X equals -1, right? So -1, 0 is an x-intercept. And then whatever's going to make this quantity 0, which is -7. So -7, 0 is our other x-intercept. Okay, our axis of symmetry, remember, is exactly in between our x-intercepts. So -1 plus -7 over 2, it's like the average between them, right? Which is -8 over 2, which is -4. Okay, so our axis of symmetry is x equals -4. Remember, the axis of symmetry is always an equation, not just a number. Okay, vertex is always on the axis of symmetry. Well, I already know my x from my vertex, which is -4. So now I need to just plug in -4 to my equation, either one for x, and solve for my y. So I'm just going to plug it into the original one. So y equals -4 squared plus 8 times -4 plus 7. So -4 squared, 16. Minus 32 plus 7, and I end up with -9. Okay, so my vertex is -4, -9. And what's my y-intercept? Well, y-intercept is always when x equals 0. So I'm going to take either equation and just figure out what my y-intercept is. I'll just plug in 0 for x. So y equals 0 plus 1 times 0 plus 7. So y equals 7. Well, then my y-intercept is 0, 7. Okay, so that's just practice going from vertex form to finding all of this other information. All right, so let's get started on this task. So you're going to just basically be using all the things that you've done and going from one version to another, using them to graph, so forth. Okay, so it says for each problem below, you're given a piece of information that tells you a lot. Use what you know about that information to fill in the rest. So they're giving you standard form right now. Y equals x squared minus 2x minus 8. You have to find the factored form, the vertex form, and the graph. So if I want to find factored form, I just need to find numbers that multiply to -8 and add to -2. So that would be -4 and 2. Okay, and since a is 1 right here, I know I can just go ahead and quickly write y equals x minus 4 times x plus 2 as my factored form. Okay, well, what that does is that gives us the x-intercepts. What's going to make this 0 is 4. What's going to make this 0? -2. Okay, so far I have 2 pieces of information for my graph. Then write the vertex form of the function. I think it's easier to start vertex form with standard form. I think it's easier anyway. So I'm going to go ahead and just rewrite the standard form, y equals x squared minus 2x minus 8. And remember to complete the square and get vertex form, I just want to start with ax squared plus bx. So x squared minus 2x. And I'm going to go ahead and take half of b and square it. So half of -2 is -1. -1 squared is 1. And then bring down this -8. Don't forget about that. And subtract the 1 that you added in there. Okay, so what this did was create for us a perfect square trinomial. So I can just do x minus, and it's going to be half of b, 1, quantity squared, and then minus 9. Okay, so now what vertex form gives us is vertex, right? So the vertex is 1, whatever h is, and -9, whatever k is. So 1, I'm going to go 1, -9. Okay, so right now I have 3 pieces of information to graph, but that doesn't really give me a good, we really want at least 5 points to sketch a smooth curve. So I'm just going to choose another x to make sure that I really know the shape of this parabola. So I'm just going to choose something, I want to choose something in between here, right? So it'll give me like something, some good curve to put in here. So I'm just going to choose x equals 3. Why not? X equals 3. So I'm going to just plug 3 into this equation and get a y. So I know I'm going to have 3 something. Okay, so y equals 3 squared minus 2 times 3 minus 8. Okay, so it's 9 minus 6 minus 8. And I have -5, right? Yeah, -5. So y equals -5. All right, so I'm going to go ahead and plot 3, -5. Okay, right now I only have 4 points, but I don't want to really pick another x. I just can reflect the point that I found over the axis of symmetry. So the axis of symmetry is right along here. This is 1, 2 away from the axis of symmetry, so 1, 2 on the other side. Okay, now I have some more points to sketch a smooth curve. So I'm just going to go ahead and try to sketch a smooth curve here and extend it out. Okay, let's try number 2. So now they're not giving us any equations, they're just giving us a graph. So we want to look at this graph and find out what exactly can we see very clearly. Well, I can see very clearly the vertex. The vertex is 2, -3. Okay, that's good because if I have to write the vertex form, then I can start by putting y equals, I'm just going to leave space in case a is something. And then x minus 2, right? Because the h is 2 squared, and then minus 3. All right, so now I'm wondering, though, if this is the same width or the same narrowness, I don't think that's a word, of the parent function, or is it wider, or is it more narrow, or whatever. So I'm just going to see what other information I know precisely from this and try to figure out what A is. So I can't really see what the x-intercepts are. I can't really figure that out. From the graph anyway, but what I can see really clearly is the y-intercept. So the y-intercept here is 0, -1. So if the y-intercept is 0, -1, and I know the vertex, like I know all the other pieces of this, then I can actually plug in all these pieces into my vertex form. And the only thing I don't know is A, right? So if vertex form is y equals a times x minus h quantity squared plus k, I know all of these pieces except for a. Okay, so let me get rid of this. All right, so y, since I'm using my y-intercept, -1 equals a. I don't know what a is. Kind of looks like it's more wide, so I'm expecting it to be a fraction. Okay, x, well, what's x when y is -1? 0. Minus, what's h? 2. Quantity squared, what's k? -3. So, -1 equals a times -2 squared, which is 4, minus 3. So, -1 equals 4a minus 3. So if I add 3 to both sides, I have 2. And so I have a equals 1/2. All right. So it is wider. So my a is 1/2. So that's how I got that. All right. So now I want to write the standard form. We just did this on the warm-up. We went from vertex form to standard form. So I'm going to go ahead and start by writing this out, like the quantity x minus 2 squared. I mean, if you really are good at figuring out what perfect square trinomials are, then you don't really have to write it out. But just for the sake of not knowing how comfortable we are with this, I'll write it out. So y equals 1/2, and then this is x squared minus 4x plus 4 minus 3. Okay, I want to distribute the 1/2, so y equals 1/2 x minus 2 plus half of 4, 2 minus 3. All right, so my standard form is y equals 1/2 x minus, oops, this is 2x, minus, what did I, yeah, minus 2x minus 1. Okay, so this is my standard form. I think going from vertex form to standard form is way easier than vice versa, but that's just me. All right, so now we're going to do number 3. In this problem, they also give us the graph, but there's different things that we can see on this graph than the previous graph, so we're going to use what we can see. And then we have to write factored form and standard form. The bummer is that we really can't see the vertex really well. Like I can guess what it is, but we're not guessing, we're doing math. So what can I see really well in the graph? Well, I can see the y-intercept. Y-intercept is 0, 10. So what can I see? I can't really see the vertex. So what can I do with the y-intercept? Well, what else can I see? I can see the x-intercepts. That's huge. Okay. So x-intercepts I can use, I'm going to just write them up here. X-intercepts. I use x-intercepts to write the factored form. So x-intercepts are 2, 0 and negative 5, 0. All right, so factored form is going to be y equals, okay, now notice that this goes down. Since it opens downward, I know this has to be, a has to be negative. So a, I'm just going to write here, a must be negative because it opens down. Okay, so I know that, but I don't know if this is more narrow or wider than the parent graph. So I need to kind of leave room to see if a is some other number than negative 1. Okay, and then I have x minus 2, almost like the opposite, times x plus 5. Okay, so I'm going to check. I'm going to do like a little check for a. The way I'm going to do that is if my equation will give me the correct y-intercept, then I know that a doesn't have to be any other number. So I'm going to go ahead and put 0, plug 0 in for x to see if I have to change my a. So if my y turns out to be 10 with the given equation, then I know I'm good. So I'm going to put y equals negative, and then 0 minus 2, 0 plus 5, y equals, and then I have negative 2 times 5. So negative 2 times 5 is 10. Okay, we're good. So I just know that a equals negative 1 because my y-intercept I knew was 10, and my equation worked out for that. Okay, so this is my factored form. All right, and then I want to write standard form. Super easy because all I have to do is FOIL this out. So I have y equals negative, and then x times x squared minus 2x plus 5x minus 10. And then I have negative x squared, negative 2x plus 5x is 3x minus 10. And then I have to go ahead and distribute that negative. So y equals negative x squared minus 3x plus 10. And then we have our standard form. Okay, so if you write an equation and you're not quite sure if it's really that graph, I mean, you can always use a graphing calculator if you have one, or you can also go ahead and use Desmos online to check. You can just plug in your equation. So real quick, I'm just going to show you on a TI-84 how you can go ahead and check your equation to see if it's that graph. So I have it has to be in y equals, okay? So I have I can put in either form actually, but I'm going to go ahead and put in this one. Okay, so I want to graph it. So I'm going to go up here to y equals, because that's my equation, y equals, and I'm going to go ahead and type in my equation. So negative, make sure that on a graphing calculator, you don't use this button as a negative right here. You want to use this button. So I'm going to put negative, and then x squared. Oops. Negative, that's silly. Negative, and then x is right here. Squared, negative x squared. And then minus 3x is just like what you usually think. The button, minus 3x plus 10. I'm going to go ahead and graph it. Okay, and I kind of want to see if that matches the graph on my paper. I mean, my window is like, oh, nothing. Graph. Yep, it matches. All right, awesome. So you can always just check it that way. All right. So let's do this last problem. So for this problem, they gave us factored form. And from factored form, we have to find the x-intercepts of the parabola. That's easy because the factored form gives us that by using zero product property. Write the vertex form of the function, okay, and then from the vertex form, we can find the vertex of the parabola. All right, and then we can graph it. So x-intercepts of the parabola are whatever's going to make this 0, this quantity. So -4 plus 4 would make this quantity 0. Remember, because x-intercepts happen when y is 0. So what's going to make this 0 is -4. And what's going to make this 0? 2. Okay, those are my x-intercepts. And if you write them just as numbers, that's incorrect. You actually need to write them as ordered pairs. Like when y is 0, x is -4. When y is 0, x is 2. All right, write the vertex form of the function. Okay, so for vertex form, I kind of like to start from at least something that resembles standard form. So I'm going to go ahead and just multiply this out, like FOIL it out as if I was going to do standard form. So this would be negative, and then x squared plus 4x minus 2x is plus 2x minus 8. Okay, so it's not really in standard form yet because I would have to distribute this. But then for vertex form, I'd have to take it out anyway. Okay, so let's kind of leave this -1 out to the side for a minute. Ignore it. I'm going to go ahead and complete the square with this trinomial. So I want x squared plus 2x, right? We start with ax squared plus bx. Take half of 2, which is 1, and square it. Okay, and then I have the -8 part, and I have to take away the 1 that I added in. Okay, so here we are. Remember? I kind of like right here. So this created a perfect square trinomial, which is x plus 1, quantity squared, minus 9. Okay, but now I need to include this -1 because I'm in my last step. So I have negative quantity x plus 1 squared. Remember, don't distribute to this. You wanted this because remember, you want vertex form. And then -1 minus 9 is plus 9. Okay, so here's my vertex form. And the vertex is really obvious from vertex form, right? HK. So H is -1. Remember, it's like the opposite of whatever's here. So -1 and positive 9. -1, 9. Okay, let's go ahead and graph this. So I know x-intercepts are -4 and 2. I know the vertex is -1, 9. Ooh, the other thing is, I know, because this is negative, I know that this is going to open down. So far, my information is accurate because I already know it's going to look like this. Okay, again, I really don't have enough points to sketch a good curve. So I'm going to choose x equals, I'm going to just choose an x somewhere in here that would make it easy for me to figure out what my curve is. So I'm going to choose just one other point, and I'm going to just say x equals 1. Like what's y when x equals 1? You know? All right, so I'm going to just plug it into, I'll just plug it into the original form. So -1 plus 4, y equals -1 plus 4, 1 minus 2. So y equals -5 times -1. So y equals 5. All right, so now I know that another point is 1, 5. So I'm going to go over here to x, go 1, 5. And again, I only have 4 points, but I really want 5. So I'm going to just sort of sketch in here the axis symmetry. And this point is 2 away from the axis symmetry. So 1, 2. So I'm going to go 1, 2 on the other side. Okay, so now I have 5 points. It gives me a better idea of sort of what the parabola looks like in here. I'm going to go ahead and try to sketch a smooth curve. And then extend there. Okay, so that is all we have for 10.8. Let me scoot this up a little bit because I realized that I was writing when you couldn't see what I was doing down here. Okay, so what I did is I just was plugging in x to the equation so I could find another point to get a good curve. All right, the next part of this task actually is this chart. I don't know if you can see it all. Oh yeah, okay. This chart that has like pieces of it and you have to find the other pieces. So like they give you standard form, you have to find all of this. Or they give you vertex form, you have to find all this. Or they give you the x-intercepts and you have to find the rest. Well, at least for Miss Webb's class, I sort of made another version of this. And for at least Miss Webb's class, that's going to be the homework for this section. So hope that helped you out. And I hope you guys have a good day and you're doing well in quarantining. I will see you in Module 11.